Hey guys, welcome back to Tech Arena, your core channel for all things tech. In today's video, we'll be creating and manipulating NumPy arrays. If you missed the previous video, I covered the basics of NumPy and why it's essential for data science workflows. You can check that out as well if you want. Creating and manipulating NumPy arrays are crucial skills for structuring our datasets before analysis or feeding them into machine learning models. So in this video, we'll learn how to create arrays using array, arange, and linspace methods, how to reshape arrays for proper structuring using reshape, and how to transpose arrays for better compatibility with data models. Alright, let's start with creating arrays. The simplest way to create a NumPy array is by using the array function. This function allows us to pass in a list or a list of lists to create 1D or 2D arrays. So first, of course, we'll import NumPy. Let's first create a 1D array using array function. Alright, now a 2D array. And here we have created a 2D array with the array function. So basically, array takes a Python list and converts it into a NumPy array. We can also create multidimensional arrays by passing a list of lists, which we just did for the 2D array. Next, let's look at the other two ways to create arrays, arange and linspace. These are great when we need to generate sequences of numbers. So first, let's use arange to create an array of evenly spaced values. The arange works like Python's range but returns an array, not a list. Here, the values I have specified are start, stop, and step values. Means I want it to start from 0, stop at 10, means excluding 10, and the step size is 2, means I want the alternate numbers. It will give us the even numbers only. If you want the odd numbers instead, just start it from 1. Alright, now let's use linspace to create an array of values spaced evenly between a range. The linspace takes values a bit differently from arange. It means that it's generating an array of numbers evenly spaced between two values. In this case, we just generated 15 values between 0 and 1. Alright, now that we know how to create arrays, let's talk about reshaping them. Sometimes the data we are working with may come in one shape, but we need to change that for our analysis or for machine learning models. That's where we need reshape to reshape our arrays. Let me show you how to reshape an array. Let's reshape a 1D array into a 2D array. Here, we first generated an array of numbers from 1 to 9 using arange, and then reshaped it into a 3x3 matrix. This is incredibly useful when we are structuring data for analysis. Keep in mind that when we reshape an array, the total number of elements has to remain the same. For example, if we have 9 elements, we can reshape them into a 3x3 array or a 1x9 array, but not a 4x4 array. I hope it's clear. Next up is transposing arrays. Transposing means flipping the rows and columns of our data. This is often necessary when we are feeding data into machine learning models, which might expect the data in a certain shape. Let's transpose a 2D array. We already have a 2D array. Let's use that. Here, I took our 3x3 array and transposed it, which swaps the rows with the columns. This can be crucial when we are working with matrices or when we need to align our data with the requirements of different models. We can also use T to transpose a matrix or an array. As you can see, we got the same result in both cases. Transposing might seem like a simple operation, but in data science and machine learning, making sure our data is in the right shape is critical. A small mistake here can throw off our entire model. So to recap, today we learned how to create NumPy arrays using array, arange and linspace. Next we saw how to reshape arrays with reshape and how to transpose arrays with transpose. These operations might seem basic, but they form the foundation of working with structured data. When we are cleaning up data for analysis or preparing it for machine learning, mastering these operations is a must.